All right, so now we're ready to actually compute some p-values for different test statistics. We have different test statistics based on whether it's left-tailed, two-tailed, t-test, z-test, and so on. Again, I have formulas written on the Google document handout about all the R commands. So I have a document written about how to actually compute p-value. What I do though is for these first three examples, I want to draw a picture and explain exactly how the p-value is working. So for the first one, what we're going to have is we're going to have it's a z-test, so that means that we're talking about the standard normal distribution. So here's our standard normal distribution. Okay, so standard normal. And that was such a good drawing, I'm going to copy it. Okay, so we'll use that for the other one. And even for the t-test. Because I can't really distinguish. Anyways, I can't draw. So the t-test looks almost like the z-test, not exactly. So if we're talking about a left-tailed, one mean z-test, what we're doing is we're thinking about if we have our actual test statistic being z is negative 1.19, our p-value is going to be the probability that our data is at least as extreme as this. So what we mean by that is we want to calculate what's the probability that our data is going to be to the extreme of 1.19. So what that means is we want to get this area. This area is going to be our p-value, whatever that area is. So what we're going to have to do in R is we're going to have to type, we want the cumulative probability up to negative 1.19. This is a left-tailed test, so that means that we're only worried about the left tail. This is all we need. Okay, so if we type p norm negative, I need both hands here, p norm negative 1.19 into R, what we end up with is 0.1170. I'm going to find my p-values to 4 decimal places. Okay, so my p-value is 0.1170. That's the p-value. That says that this area over here, which I'm coloring in purple now, but that purple area is 0.1170. That's what that says. And so the second half says at the 5% significance level, do the data provide sufficient evidence to reject the null hypothesis or not? And since our p-value, so this is our p-value, since p is bigger than alpha, right, we have 0.117 is bigger than our alpha, which is 0.05. That means that we do not reject. Okay, we fail to reject the null hypothesis. Okay, so we do not reject the null hypothesis. All right, and that's how that works. If p is bigger than alpha, we do not reject. If p is less than or equal to, we do. Okay, so if p is less than or equal to alpha, we do reject. And that's it. So next, number 2, we're going to look at a two-tailed z-test where z is 2.85. 2.85 is a positive value, so that's over here. And what we're going to do is we're going to look at the probability that our data, a random sample rather, is at least as extreme as our data. So we're going to look at that area. And because it's a two-tailed test, we not only have to worry about the area to the right, we also have to worry about the area to the left. And so we have to think about, if we were to have negative 2.85, we're going to add to it those two areas. Okay, so if we sum those two values, if we sum the area of the left tail and the right tail, that sum is going to be our p-value. Okay, so that's how we get the p-value for a two-tailed one-mean z-test. And so what we're going to do is we're going to plug this into R, and the way that we're going to do this is I want the cumulative probability up to negative 2.85. That part's easy. Right, we have p norm negative 2.85, And we're going to add to it this area over here to the right. Now it turns out, by symmetry, that this left area is going to be exactly the same as the right area, because we know that the z-distribution is symmetric about the y-axis, right? So we know that those two areas are going to be the same. So what we can do is we can find the easier area to find is the one over on the left, because we're always talking about cumulative probabilities with the p-norm function. And so if we want the p-value, we can just take that value that we found of the cumulative probability up to negative 2.85, and we can multiply by 2. Okay, so if you type 2 times p-norm of negative 2.85, and I'll type that into R, so negative 2.85, what we end up with is we get a p-value that is 0.00437, but I said I would round to 4 decimal places. It's really 0.0004371 blah blah blah. But if we round to 4 decimal places, that would be 0.0044. Okay, so there's our p-value. At the 1% significance level, do we reject the null hypothesis or not? And the answer is yes. Because p is less than or equal to alpha, we reject. And again, remember, p was our value 0.0044, and our alpha was our significance level. That's the 1% significance. Okay, so 1% significance, so we do reject. Okay, so in that case, we do reject. All right, one more for the video. For number 3, we want to find the value of a test statistic for a two-tailed, one-mean t-test where t is negative 1.71. I forgot one piece of information here. I wanted, I can say this one in 2 ways. I wanted our n to be 25, or I want our degrees of freedom to be 24. That's what I meant there. And so we have negative 1.71. Again, remember the t-distribution is not exactly the same as the z-distribution, but they're close enough. I'm going to use the same graph. So if we want to find the p-value, what we're going to have to do is use the built-in functions on R to get the exact value. So this is a two-tailed test, so we're going to have to worry about the cumulative probability up to negative 1.71 and the area to the right of positive 1.71. So we'll again do the trick that we did in number 2, and we'll find the cumulative area, the cumulative probability up to negative 1.71, and then just multiply by 2. That gives us the right area, again by symmetry. And so if we want to do that, what we're going to do is we have to use a new function. Before we used p-norm, right, for the normal distribution, here we're going to use pt, okay, for the student's t-distribution. So our p-value is going to be, it's again two-tailed, so that means that we're going to multiply by 2 times pt. We're going to want to find the value up to negative 1.71, and then we want our degrees of freedom to be 24. And if we plug that into R, what we're going to get is 2 times pt, negative 1.71, with 24 degrees of freedom, tells us that our p-value is 0.10002. It's really 0.1001654, but again, we round to 2 decimal places. There we go. So that is our p-value for this, for our data set. And then at the 5% significance level, do the data provide enough evidence to reject or not? And the answer is no, do not reject. And again, the idea is that our p-value, which was our 0.1002, is greater than or equal to our significance value, which was 5%. Okay, so our p was not just greater than or equal to, we want it to be strictly greater than alpha. 0.05, and we're done. Okay, so that's essentially the p-value approach. What we'll do in the next video is run through a few examples and actually go through and do this again.